Okay, so the first examples that we're going to do today are on adding polynomials. Now, up here in the red box, I gave you three bullet points that you really want to keep in mind as you're doing these. To make this the easiest and fastest way to do it, you always want to start with the highest exponent first. And that means that you need to scan through the whole entire problem and see who has the highest exponent and then begin with that one. And then decrease by one every single time until all of your numbers are taken care of. The second thing is, once you identify where your like terms are, you're going to add the coefficients. You always add them. So this is where your skills for adding positive and negative numbers comes in. So just be careful with your signs. And lastly, when you're adding like terms, you always keep the variable and the exponent the same. So if it starts off in x squared, it's going to stay in x squared. Okay, so what I want to do is get started. So I'm going to pick some colors out because as we go through and identify our like terms, I'm going to circle them with different colors. If you have colored pencils or highlighters, this would be a great place to use them. Otherwise, you can use different shapes, like I've used circles and underlining and squares and triangles, just to distinguish between them so that they don't get lost in the shuffle. Okay, so in the examples that I'm pulling are straight from the textbook, and I picked 2, 8, and 10 as the problems that we're going to highlight and focus on for our adding polynomials section. So the first thing I want to do is scan this. And the highest exponent I see is just x to the first. There's no x squareds or anything like that. So I'm going to circle a positive 6x, and I'm going to circle its like term, negative 7x. And then I'm going to combine them. So I'm going to do 6 plus negative 7. And when I do that, 6 plus negative 7, that's going to give me negative 1, and I keep the x the same. Then the next term down from x to the first is x to the 0, which is no x values at all, which are constants. So here I would have 1 plus 2, and that is 3. So my final answer is negative 1x plus 3. And that's how you would leave it. And notice I did them in different colors so that you could see exactly where they came from. You don't have to do that on your homework. It's just a helpful suggestion. The second one I want to look at is number 8. The highest exponent in both of these is x to the 4th. So I'm going to start with 6x to the 4th. And I'm going to see if there's anything I can add to it. And the answer to that is no. There's no other x to the 4ths here. So you're going to bring that over. That is the first term. And it's all by himself. The one down from x to the 4th is x to the 3rd. So I'm looking for x to the 3rds. And I see I've got an x to the 3rd here. And I've got no other x to the 3rd. So again, I'm just going to bring him over. Like so. The next one that I have is x squared. So I'm going to look and see, do we have any x squareds? And yep, there's one. And it's a positive 4x squared. There's nothing to add to it, so I'm just going to bring over 4x squared. The next term is my x terms. And in my x terms, I'm looking for just x's. There it is. There's no other ones that I'm adding, so just negative 3x. And then lastly, x under x to the first is x to the 0, which is no x's, and that's negative 1 up plus 3. And negative 1 plus 3 is positive 2. What this does is this allows us to not only add our polynomials correctly, but it puts our answer into descending order, which is our standard form. So the final answer for number 8 is 6x to the 4th plus 3x to the 3rd plus 4x squared minus 3x plus 2. Notice the only thing that we could combine in all of this mess was the constants. So look out for that, okay? If you're adding polynomials, then in a singleton all by itself, then you just bring it over. If Here's our last one. And our last one looks a bit more complicated. I need to move this a little bit. But it's not terrible. It's just decimals. Okay. So what we're going to do is start the same exact way. We're going to start with x to the scanning. Fourth is the highest one. So I've got an 0.5x to the fourth here. And I have a 2.3x to the fourth here. And I'm going to add them. So when I add them, I'm going to take 2.3 and I'm going to add 0.5. And that's going to give me 2.8 x to the fourth. I'll do it underneath. Then what we want to do is we want to take the next term and we want to scan. So the next term I'm looking for is x to the thirds. So I've got an x squared, no x is here, an x, and no x is here. So there's no x to the third, so we can skip that one. And we're going to go straight to x squareds. I know I saw an x squared in here. There it is. And it's not being added to any other x squareds. There's some other x squareds here, so I'm just going to bring it down. Negative 0.6x squared. After an x squared is the x terms. I'm looking for plain old x's. This doesn't have one. Here it is. Here's one. And that's not being added to anything, so I'm just going to bring that down. And then, of course, we've got our constant, which is our last little bit there. And that's 0.7 plus a negative 3.9. So when I add those together, I'm going to get negative 3.2. So this is the answer to the polynomial in standard form with the highest exponent down to the lowest exponent. What you're going to do on the next slide is you're going to try 2 on your own and then check the answer with me, and then we'll move on to the next concept.